In this video, I'm going to compare and contrast the OSI model with the TCPIP model to give you a better understanding of both and the differences between them. After that, we'll actually run a telnet session in our packet tracer lab and see the layers of the OSI model as we step through that telnet session. So to understand the OSI and TCPIP models, we need a little bit of background real quick. Back in the 60s, the Department of Defense awarded contracts to develop packet switching networks, and one of those contracts led to the development of the ARPANET by DARPA, which is a defense organization for advanced research projects. Now, they developed the TCP/IP protocol and sent the first message from a node at UCLA to a node at Stanford. And then we're talking about the TCP/IP model over here. They developed TCP/IP, which would be at the transport layer, and IP, which is at the internet layer. And using those two, they were successful in sending a message from UCLA to Stanford. Now, the TCP/IP model is essentially a conceptual model. It's how you think about the TCP/IP protocol and applications that interact with it, and the network access that interacts with it as well. And it specifies how packets should be handled between the nodes in end-to-end communications. So that's essentially how TCP/IP began. The TCP/IP protocol itself began in part of this conceptual TCP/IP model. That was back in the 60s. Then in the 70s, there were two different models were developed by different international standards committees. One was in the US, that was the ISO, and the other was a French committee. And then it took a few years, and then finally in the 80s, both of those merged into a single document, which we now know as the OSI model, which is our 7-layer model. Similar to the TCP/IP model, it's an abstract model, a way to think about networking and how things interact with each other at each of the different layers. But it's also a model that describes the protocols at each of the layers. Of course, it's one of the main differences and the easiest to see, and the one that you'll see prevalent whenever you research the difference between the two, is that OSI has 7 layers and TCP/IP has 4 layers. But another difference is that the OSI specifies, very more specific than TCP/IP, it specifies the protocols like TCP/IP at each of the 7 layers. The OSI model evolved from other models, and one of those is ARPANET's model, the TCP/IP model. But it was also influenced by a handful of other models, not just the TCP/IP model. So the protocols in the OSI model enable entities in any of the 7 layers to communicate with each other. The main idea behind it is that entities at higher layers interact with those at lower layers, and lower layers they facilitate a way for those at higher layers to interact with them. So as an example, if TCP is at the transport layer and IP is at the network layer, IP is written in a way that any protocol written at the transport layer can interact with it. So it's not just limited to TCP/IP here. UDP interacts with the network layer, and further on down the line, back in the day when TCP was developed, there wasn't such a thing as RTP, real-time protocol. Now there is, so that you can continue to write more protocols at any of the layers, and because of the way the lower layers are written, it allows these layers at the higher level, such as RTP, to interact with layers that already exist at lower layers. So the other thing that is of mention is that the OSI is concerned with strict encapsulation and layering, whereas TCP/IP is a little bit looser on that. So that's where the TCP/IP interconnects with IP on the network layer, and it facilitates the higher layers communicate with lower layers, and the protocols are written in a stricter sense than that of the TCP/IP model. Okay, so that's the background of it. Now let's actually look at some of the layers as we step through a telnet session from PC0. And you can download this lab on econfigs.com and run through it yourself if you want to do other things other than just telnet. We have the IPs configured. 192.168.1.1 is our router, so we're going to actually initiate a telnet session from PC0 to our router. And before we do that, we want to put the packet tracer in simulation mode so that we can step through each of these connections and we can see the stack as it's going. So we see we're at device the PC0. It's a TCP traffic And what we've done so far, all we've done is hit enter. So we said from device 0 going out, it's going out fast Ethernet 0, which is, let's see if we can minimize that. Here's our layer 1, physical, fast Ethernet 0. Here's our layer 2, data link, which shows you our MAC addresses. Here's our layer 3, which shows you the IP addresses, our network layer, and our layer 4, which shows you the port that it's on, which is port 23 for Telnet. And our layers, and actually you can click on each of these and see layer 7 is Telnet, and you can get more information as to exactly what's happening. So we'll continue to step through just a couple times just to give you an idea of how this happens. The packet heads up the switch 0, or heads up to the switch, and the switch is a layer 2 device, so it goes no higher than layer 2. It comes in on port 02, it sees the Ethernet header, layer 2, it sends the Ethernet header out port 01. And so our next one should be over to the router. So the router sees TCP, and we'll continue to go until we see a telnet, but you're getting the idea here. Let me get that back out. The router sees it come in port 00, layer 2, layer 3 IPs. Destination port is port 23, telnet. Step through again, and it sends it back. So this is essentially your handshake. The PC is saying, hey, I want to communicate on telnet, and so there you go. So the PC sends its SYN act back, and then it starts, it acts, and then it starts its telnet session here. So let's look at the actual telnet. Let's look at one of these, see what it has. And again, it's very similar. It says, okay, I'm going out port 0. Here's my Ethernet header, layer 2, layer 3 IPs. Layer 4 is on port 23, and I'm a telnet session. So let's see if it actually, let's go back to here, and you can see that our telnet session is trying to open it. If we continue to step forward, we should see, once it gets back to the PC, that it's open, unless it times out on us. There we go. So our telnet session came back to PC 0, and that's when we had the open. So now we're open our telnet session to R0, so the router is open, and we could see each of the packets as they went through the network and the layers that they are associated with in our OSI model. So hopefully that explains the differences between the two models, and then you got to take a look at actually how a telnet session, just one example, goes through each of the layers of the OSI model. And we're going to do this more in another video. The next video talks about TCP and UDP and the differences between both, so we'll step through in a little more detail how those look at the OSI model as well.